When we look at a pre-engineered building, or PEB, we normally notice the main structural members first: the columns, rafters, roof framing, and the overall steel structure. But a real PEB is not made only from these large members. There are many smaller secondary members that work together with the main structural system to complete the building. One of these members is called a sag rod. You may have already seen the term sag rod on a PEB roof framing drawing. At first look, it may appear to be just a small steel rod placed between the roof framing members. But for someone learning PEB detailing or drawing reading, it is important to understand exactly what this member represents and why it is shown in the structural drawing. So, what is a sag rod? In simple terms, a sag rod is a secondary steel rod used in association with secondary framing members such as roof purlins, as specified by the structural design. It is a relatively small member compared with the main columns, rafters, and purlins, but it forms part of the overall secondary framing arrangement. To understand the concept properly, we should not look at the sag rod as an isolated member. We need to understand its relationship with the roof purlins. A PEB roof normally contains a series of purlins arranged along the roof. These purlins support the roof system and transfer the applicable loads toward the primary structural frame. The sag rod is provided as part of this secondary framing system to provide restraint and help maintain the required position and stability of the purlins, according to the project design. This is why the sag rod appears as a much smaller member compared with the main roof framing members. And this is also why identifying it correctly in a PEB drawing is important. When you are looking at a complicated roof framing plan for the first time, there may be many different lines representing different structural members. Some lines represent purlins. Some represent bracing. Some represent sag rods. And some lines may represent grid lines, dimensions, or other drawing information. Therefore, we should never identify a member only by looking at the line visually. We should always look at the member name, its location, and its relationship with the surrounding structural members. In our real PEB project, the roof framing drawing specifically identifies sag rod along with other roof framing components. That gives us a practical opportunity to understand how this small member is represented in an actual engineering drawing and how that information translates into a real three-dimensional PEB structure. So, the main point to remember from this first slide is very simple. A sag rod is a secondary rod member associated with the purlin framing system, provided as specified by the structural design to help restrain and maintain the secondary members. It is not the same as a roof purlin, and it should also not be confused with rod bracing. We will understand those differences in detail as we move through the next slides. For now, just remember one basic relationship. Primary frame supports the secondary framing system. Purlins form the main secondary roof members. Sag rods provide the required restraint within that secondary framing arrangement. Once this basic relationship is clear, reading the sag rod markings on an actual PEB roof framing plan becomes much easier. In the next slide, we will move from this overall 3D view to the actual roof framing plan of the project and identify exactly where the sag rods are shown. That is where the concept will start becoming much clearer. So, let's move to the real roof framing drawing and locate the sag rods. Now let's look at the end wall framing elevation of our real PEB project. This drawing gives us a front elevation view of the building end wall, including the roof, rafters, roof purlins, side girts, louvers, cladding, and other framing components. And in this particular view, we can clearly identify an important secondary structural member called the sag rod. Look carefully at the wall framing area. On the left side of the elevation, the drawing specifically shows the label sag rod inside the wall framing zone. A similar sag rod indication is also shown on the right side. So, the drawing itself confirms that sag rods are provided within these framing areas of the end wall. Notice that the sag rod is not the main vertical column and it is not the horizontal girt itself. Instead, it is a secondary member associated with the framing system. In this elevation, the sag rod is shown within the framing bay, while the horizontal members are identified separately as GIRT. This distinction is important when reading a PEB general arrangement drawing. When we are working with PEB drawings, simply knowing the name of a member is not enough. We should also understand where that member is located and how it appears in different drawing views. Here, the end wall framing elevation allows us to identify the sag rod directly in the wall framing. Later, when we compare this information with the roof framing plan and the 3D model, we can understand how the same type of secondary member is represented from different viewpoints. Also observe the surrounding framing. The elevation contains the main steel framing, horizontal girts, roof-related members, louvers, side cladding, and the masonry portion at the bottom. The drawing also shows a clear height of 9,150 millimeters, along with the grid and dimensional information for the end wall. So the key point from this slide is simple. When you see the label sag rod in an end wall framing elevation, identify its exact location within the framing bay and distinguish it from the adjacent GIRT and main framing members. This is the first step toward correctly understanding and detailing the member in a real PEB project. In the next slide, we will move closer to the actual framing and examine the sag rod location and its relationship with the surrounding members. That will make the drawing much easier to understand before we move toward the real 3D model. Now, in this slide, we are looking at the side wall framing elevation of our real PEB project. This view is very useful because it allows us to understand how the different secondary framing members are arranged along the side wall. Instead of looking at the complete 3D model, we are now focusing specifically on the side wall elevation so that we can identify the sag rod location clearly. First, look at the left side of the drawing. Inside the side wall framing, we can see the label sag rod. The same sag rod indication is also visible on the right side of the building. So, from this drawing, we can clearly identify the locations where sag rods are provided within the side wall framing. Now look carefully at the relationship between the sag rod and the surrounding members. The side wall contains several horizontal framing members, which are identified as GIRTs. The sag rod is shown within this framing arrangement. This is important because when we study a PEB drawing, we should not identify a member only by its name. We should also understand where that member is located in relation to the other structural members. Here we can see the label GIRT separately from the sag rod label. This tells us that these are different members and should not be confused with each other. The Girt forms part of the side wall framing system, while the sag rod is a separate secondary member shown within the framing arrangement. For anyone learning PEB detailing, this distinction is very important. When reading a general arrangement drawing, always check the label, its position, and the member geometry together. Now move your attention toward the middle portion of the side wall. We can see the rod bracing arrangement forming diagonal X patterns in the braced bays. These diagonal members are different from the sag rods. So, within the same side wall elevation, we can have several different types of secondary steel members working together. The drawing therefore gives us a good opportunity to understand the difference between girts, sag rods, and rod bracing. Another important point is the bay arrangement. At the bottom of the drawing, the grid numbers are shown from 1 to 7. The steel column spacing is dimensioned between these grid locations. The drawing also gives the overall steel line dimension and the individual bay dimensions. This helps us understand exactly where the side wall framing members are positioned within the building. Why is the sag rod location important? Because when we move from a 2D drawing to a 3D PEB model, we need to know exactly where the member belongs. If we understand only the name sag rod, but do not understand its location in the framing system, it becomes difficult to model or detail it correctly. The elevation gives us the first important information: which framing area contains the sag rod. Then, in the next stages, we can use other project views and the 3D model to understand its actual arrangement and connection. Also notice the other information shown in this elevation. We can see S-type louvers, end cladding, end girt, canopy, RS, and the masonry portion at the lower level. These elements occupy different portions of the side wall. Therefore, when reading this type of drawing, we should not look at the sag rod in isolation. We should understand its location within the complete side wall framing arrangement. This gives us a very useful method for reading PEB drawings. First, identify the main framing members. Second, identify the secondary framing members. Third, locate the bracing members. And finally, identify the smaller secondary components such as the sag rod and understand where they are positioned relative to the surrounding members. Following this method makes a complex PEB drawing much easier to understand. Remember, our final objective is not just to read this 2D drawing. We want to understand how the same information appears in a real PEB 3D model. In the 2D side wall elevation, the sag rod is represented as part of the framing arrangement. When we later look at the 3D model, we will be able to see the actual spatial position of the member and understand how it fits into the surrounding structure. This is where 2D drawing interpretation becomes much more useful for practical PEB modeling and detailing. So, the main learning from this slide is, The side wall framing elevation helps us identify the location of the sag rod within the side wall framing system and distinguish it from the girts and rod bracing. Always read the member label together with its actual location and surrounding framing. That approach will help you avoid confusion when moving from the general arrangement drawing to detailed modeling. Now that we have identified the sag rod location in the side wall framing, the next step is to understand how this member appears in another view of the PEB structure. This will help us connect the 2D drawing information with the actual arrangement of the member in the building. So, let's move to the next slide and continue our sag rod analysis from the real PEB project. Now let's move to the roof framing plan of our real PEB project. In the previous slide, we identified the sag rod in the side wall framing elevation. Now we are looking at the roof from the top, and this view gives us another important perspective for understanding where the sag rods are located within the overall PEB framing system. This is important because the same structural member can look very different depending on which drawing view we are studying. First, look at the upper left portion of the roof framing plan. Here we can clearly see the label sag rod. Now look toward the upper middle portion of the roof. Another sag rod label is visible there. We can also see corresponding sag rod locations toward the upper right portion of the roof framing plan. Now move your attention toward the lower half of the drawing. Again, we can see sag rod indications on the left, middle, and right portions. So this roof framing plan clearly shows multiple sag rod locations distributed across the roof framing arrangement. Remember that this is a plan view. That means we are looking at the building from above. Because of this, the roof framing members are represented in a horizontal plan arrangement rather than as a vertical elevation. This is different from the side wall elevation we studied previously. In the side wall elevation, we were looking directly at the wall framing. Here, we are looking down onto the roof framing system. Understanding this difference between plan view and elevation view is extremely important when reading PEB drawings. Now look at the labels around the sag rod locations. We can see roof purlin labels in the roof framing plan. The sag rod indications are located within the roof framing arrangement alongside these roof purlins. This gives us an important visual relationship. When reading this drawing, we should identify the sag rod together with the surrounding roof purlins rather than looking at the sag rod label alone. Now there is another very important point. This roof plan contains both sag rod and rod bracing. These two labels must not be confused. Look at the areas marked rod bracing. There, we can clearly see diagonal members forming large X-shaped arrangements between the framing lines. These are identified separately as rod bracing. The sag rod labels, on the other hand, are shown in other portions of the roof framing arrangement. Therefore, when reviewing a PEB drawing, always pay attention to the exact label and the exact location of the member. Now look at the large X-shaped bracing arrangements. There are braced zones on both sides of the ridge line. The diagonal lines extend across the framing bays and are specifically identified as rod bracing. This gives us another useful lesson. A single roof framing plan can contain several different types of rod members. Some are identified as sag rods, while others are identified as rod bracing. Therefore, simply seeing a thin line in the drawing is not enough to identify the member. We must read the drawing annotation and understand the member's position. Now look at the center of the drawing. The horizontal center line is identified as the ridge line. The roof slopes away from this central ridge. The drawing also specifically indicates the roof slope as 1:10 on both sides of the ridge. This helps us understand the overall roof geometry. So when we look at the sag rod locations in this plan, we should also understand where those locations are in relation to the ridge line and the two roof slopes. The roof is divided into several framing zones. The grid lines running across the building help define these areas. We can see grid references A, B, C, D, and E along the side of the plan. Similarly, the longitudinal grid references are shown from 1 through 7. These grid references are extremely useful when locating any particular framing member. Instead of simply saying that a sag rod is somewhere on the roof, a detailed drawing allows us to identify its position in relation to the building grids. Now look at the dimensions around the roof plan. The drawing shows individual bay dimensions such as 7,315 mm and 7,765 mm. It also shows the overall steel column spacing dimension of approximately 45,690 mm center to center of steel columns. Another dimension indicates approximately 46,600 mm overall steel line. These dimensions help us understand the overall size and arrangement of the roof framing system. For a PEB detailer or modeler, these dimensions are important because the location of every framing component has to correspond with the actual building geometry. Now come back to the sag rods. Notice that the sag rod labels are not randomly placed. They appear within specific roof framing areas. For example, we can identify sag rod indications in the upper roof zones and again in the lower roof zones. This repeated arrangement gives us a clear visual indication of how the sag rod locations are distributed within the roof framing plan. This is one of the advantages of studying the complete roof plan instead of looking at only one small detail. Now compare the sag rod locations with the roof purlins. The roof purlins run across the roof framing arrangement and are identified at multiple locations. The sag rod labels appear in relation to these purlin zones. This is exactly the kind of information that becomes useful when we later examine the actual 3D PEB model. The 2D drawing tells us where to look. The 3D model will then help us understand how the member is physically arranged in space. This is also why we should never depend on only one PEB drawing when trying to understand a structural member. In our project, we have already looked at the end wall framing elevation. Then we studied the side wall framing elevation. And now we are studying the roof framing plan. Each view gives us different information. The elevation helps us understand the member vertically. The roof plan helps us understand its position within the roof layout. When these views are studied together, the overall framing arrangement becomes much easier to understand. In the previous side wall elevation, the sag rod was seen within the vertical wall framing arrangement. Here, because we are looking from above, the the same type of member is represented within the roof framing layout. This is an important drawing reading skill. The appearance of a member on a drawing can change depending on the viewing direction. Therefore, we should always identify the drawing type first. Here, the drawing title clearly tells us, Roof Framing Plan. So our interpretation should be based on a top-view roof framing arrangement. Another feature visible in this roof plan is the canopy at both sides near the lower portion of the drawing. These canopy areas are located outside the main roof framing arrangement. They are shown separately from the central roof framing system. This is another reason why the grid and dimension information is useful. It helps us distinguish the main building framing from the additional structural projections. For practical PEB detailing, this slide teaches us an important workflow. First, locate the member in the general arrangement drawing. Second, identify the surrounding structural members. Third, check its position relative to the building grids. Fourth, compare the information with another elevation or plan. And finally, verify the arrangement in the 3D model. This approach reduces the chance of misunderstanding a member when moving from drawings to modeling. So, what have we learned from this roof framing plan? We can clearly identify multiple sag rod locations. We can see the relationship between the sag rod locations and the roof purlines. We can distinguish sag rods from the separately identified rod bracing. We can identify the central ridge line. We can understand the 1:10 roof slope. And we can use the grid and dimension information to understand where these members are positioned within the overall building. The most important point from this slide is, the roof framing plan helps us understand the location and distribution of sag rods within the roof framing arrangement. But remember, this plan alone does not give us the complete three-dimensional picture. For that, we need to continue into the actual project model and examine how these members are physically positioned. So far, we have studied the sag rod from different 2D drawing views. We have seen its location in the framing elevation. We have now seen its location in the roof framing plan. The next logical step is to move from 2D drawings to the real 3D PEB model. There, we can visually understand the actual position of the sag rod in relation to the roof purlins and the rest of the steel framing. So let's continue to the next slide and see how the sag rod appears in the real PEB 3D model. Now let us move from the roof framing plan to the real 3D model and identify how the sag rods appear in an actual PEB structure. In this 3D view, we are looking directly at the roof framing system where multiple roof purlins are arranged across the building length. The purlins are the main secondary roof members supporting the roof sheeting. But if we look carefully between these purlins, we can also see the slender rod members connecting the purlins together. These are the sag rods. The important point to understand here is that a sag rod is not a roof purlin and it is not roof bracing. It is a relatively slender secondary member provided between adjacent purlins to help maintain their position and provide intermediate support against sagging or lateral movement. Now compare this 3D model with the roof framing plan we saw in the previous slide. In the roof plan, the sag rods were represented using simple lines and labels. But in the 3D model, we can understand their actual physical location much more clearly. We can see that the roof purlins form the repeated framing lines, while the sag rods connect between these purlins. This is one of the advantages of studying a real 3D PEB model. A two-dimensional drawing tells us where a member is located in plan, but a 3D model helps us understand how that member actually exists inside the structural system. When looking at a PEB roof, it is very easy for a beginner to confuse sag rods with other slender members such as rod bracing. So remember the basic difference. Sag rods are associated with the purlin system, while rod bracing is part of the structural bracing system. Their appearance may look similar in a drawing because both can be represented by thin lines, but their location and structural function are different. In this model, the roof purlins repeat from one frame line to another, and the sag rod system works along these secondary members. This arrangement helps the purlins work together more effectively and maintains the required alignment of the roof framing. Another important observation is that sag rods are much smaller compared with the main structural members. The primary rigid frames, rafters, columns, and major secondary members have much larger structural dimensions. The sag rods, on the other hand, appear as relatively thin rod members. That is why they can be difficult to identify when looking at a complete PEB model from a distance. For a drafter or detailer, this is particularly important. When preparing or checking PEB drawings, we should not simply identify a thin line and assume that it is a bracing member. We should first understand which structural member it connects to, where it is located, and what system it belongs to. In the next step of our PEB learning, this understanding will help us read sag rod arrangements directly from framing drawings and then locate the same members correctly in the 3D model. So, from this real 3D model, remember one simple concept. The roof purlins form the repeated secondary framing system, and the sag rods are slender connecting members provided between the purlins. Once you understand this relationship, reading sag rods in a PEB roof plan becomes much easier. And this is exactly why we are studying the 2D drawing and the real 3D model together. Now let us take a much closer look at the roof sag rod connection in this real PEB 3D model. In the previous slides, we identified sag rods from the framing drawings and then saw their overall arrangement in the roof 3D model. But when we look at the complete building from a distance, the sag rod is a very small member and its actual connection can be difficult to understand. So in this slide, we are zooming into one specific location to understand exactly where the sag rod is positioned between the roof purlins. Here, the two large purple members represent the roof purlins, and the slender dark green member running between them is the sag rod. The important thing to notice is that the sag rod is not another roof purlin. It is a secondary supporting and stabilizing member provided between adjacent purlins. When several purlins are arranged along the roof slope, each purlin has a certain unsupported length. The sag rod is introduced between these purlins to provide intermediate restraint and help maintain the alignment and stability of the purlin system. Now look carefully at the way the rod passes through the purlin locations. The rod connects from one purlin to the adjacent purlin. This is the important visual relationship that we need to understand from the 3D model. In a 2D framing drawing, this connection may appear as only a small line or a simple symbol. But in a real 3D model, we can clearly see that the rod physically connects the purlin locations and forms part of the secondary framing system. This close-up view is especially useful for a draftsman or detailer because it helps us understand how the member shown on the drawing is actually represented in the steel model. Another important point is that the sag rod should not be confused with rod bracing. Rod bracing and sag rods may both appear as slender rod members, but their locations and functions within the PEB framing system are different. In our earlier slides, we saw X-shaped rod bracing in the roof framing plan. Those diagonal members form a bracing arrangement within selected bays. Here, however, we are looking at a sag rod connecting adjacent roof purlins. So when reading a PEB drawing, we should always identify the member according to its location, arrangement, and drawing reference, rather than identifying it only by its appearance. Now look again at the close 3D view. The roof purlins are the largest structural members. The sag rod is much smaller in comparison. This difference in size is one of the reasons why sag rods can easily be overlooked when looking at the complete 3D model. But although the member is small, it plays an important role in the overall roof framing arrangement. For a structural detailer, this is an important lesson. A member does not become unimportant simply because it is small. Small secondary members such as sag rods, flange braces, bridging members, and other connection components must also be correctly located and detailed. Now let us understand the connection visually. At one side, the sag rod approaches the purlin. At the other side, it continues toward the adjacent purlin. This creates a connection between the two purlins. The exact connection hardware, hole arrangement, rod diameter, washer, nut, and connection plate should always be taken from the applicable project detail or connection drawing. So we should not assume dimensions or connection specifications simply from this 3D view. The purpose of this slide is to understand the member location and its relationship with the purlins. This is also why a close-up 3D view is extremely useful during PEB detailing. A general 3D model helps us understand the complete building, but a close-up view helps us understand the actual position of a small structural component. When we combine both views, the drawing becomes much easier to understand. First, we identify the sag rod in the framing plan. Then we locate the corresponding purlins. Then we look at the 3D model. And finally, we zoom into the connection. This step-by-step approach helps us connect the 2D engineering drawing with the real 3D steel model. For anyone learning PEB detailing, this is a very useful workflow. Do not look at the drawing only as lines on paper. Try to imagine how every line becomes an actual steel member in the final structure. The roof purlin shown in the drawing becomes a physical cold-formed or secondary steel member in the model. The sag rod shown between purlins becomes an actual rod connecting those purlins. And the connection shown in the detail becomes the physical connection between the members. That is the real value of studying a PEB project through both drawings and 3D models. So, from this close-up view, there are three things we should remember. First, the larger members are the roof purlins. Second, the slender member connecting the purlin locations is the sag rod. Third, the sag rod should not be confused with the main roof bracing system. This close-up also gives us a better understanding of why the sag rod is repeated at different locations in the roof framing. It is part of the secondary framing arrangement and works together with the purlins to maintain the required structural behavior and stability. As we move through the remaining slides of this project, we will continue to identify these small members directly from the real PEB model. The objective is not only to know the name of a member. The objective is to understand where it is located, what it connects to, how it appears in the drawing, and how it is represented in the actual 3D structure. Once you start looking at PEB models in this way, even small members become much easier to identify. So remember this close-up view. Roof purlin to roof purlin, connected by the sag rod. That simple relationship is the key point of this slide. And this is exactly how we should read a real PEB project, from the drawing, to the location, to the 3D model, and finally to the actual connection detail. Now let us move from the roof framing to the sidewall framing of the same real PEB project. In the previous slides, we studied the roof sag rods and looked closely at how they are arranged between the roof purlins. In this slide, our focus is different. Here, we are looking at the side wall sag rods in the actual 3D model. This is important because the same basic idea of secondary member support can also be seen in the side wall framing system. When we look at the complete side wall in a 3D model, there are many members visible at the same time. We can see the main steel columns, horizontal side wall members, diagonal rod bracing, and other secondary framing components. Because all of these members are relatively close to each other, it can sometimes be difficult for a beginner to identify exactly which member is the sag rod. So in this slide, instead of looking only at the complete building, we will concentrate on the side wall framing arrangement and understand how the sag rod is positioned within this system. First, look at the overall side wall. The vertical members are the steel columns. Between these columns, we have the horizontal secondary members forming the side wall framing. These horizontal members are important because they support the side wall cladding and transfer the relevant loads back toward the primary steel framing. Now, within this secondary framing arrangement, the sag rod provides additional support and restraint to the side wall members. The important thing to understand is that the sag rod is a secondary member. It is not the main steel column. It is not the main side wall girder. And it should also not automatically be identified as rod bracing simply because it is a slender member. This distinction is very important when reading a real PEB model. If we look at a typical side wall framing elevation, the side wall contains multiple horizontal members at different levels. The sag rod works in relation to these secondary members and helps maintain their stability and alignment. So when you look at the 3D model, do not try to identify the sag rod only by its size. Instead, look at where the member is located and what members it is associated with. This is one of the most useful habits for a PEB detailer. Now compare this view with the roof sag rod that we studied in the previous slide. On the roof, we saw the sag rod working between roof purlins. Here, we are looking at the side wall secondary framing system. The overall principle is similar. A small secondary member is provided to support and stabilize the framing system, but the actual location and arrangement depend on the project design. That is why we should always refer to the actual project drawing and 3D model rather than assuming that every PEB building will have exactly the same arrangement. Now let us look at the side wall bays. The columns divide the side wall into individual framing bays. Within these bays, the horizontal secondary members repeat at different levels. The diagonal members that you can see forming X-shaped patterns are the rod bracing. These members have a different arrangement from the sag rods. This gives us an important visual clue. X-shaped diagonal members are part of the bracing arrangement, while the sag rod belongs to the secondary framing support system. So, when studying a PEB model, we should not mix these two systems together. The bracing provides a specific load-resisting function within the building structural system. The sag rod is associated with the secondary framing members. Understanding this difference will make it much easier to read both the 2D drawings and the 3D model. Now look at the side wall again. The repeated horizontal members create a regular framing pattern. If we were looking at this model during actual detailing work, we would need to identify the correct locations of the sag rods and make sure that their connections correspond with the project drawings. This is where the combination of drawing, reading, and 3D modeling becomes very useful. A drawing may show the sag rod using a simple line and a label, but the 3D model allows us to understand where that line actually exists in the physical structure. This is especially useful for someone learning PEB detailing. Instead of memorizing only the definition of a sag rod, we can understand its actual location inside a complete steel building. Now imagine looking at this model without knowing what a sag rod is. At first, the number of members can look confusing. There are columns. There are horizontal girts. There are roof members. There are diagonal rod braces. And there are smaller secondary members. But once we understand the function and relationship of each member, the model becomes much easier to read. This is the main purpose of studying a real project. We are not simply learning individual member names. We are learning how those members work together as one structural system. Now let's focus again on the side wall sag rod. Its importance comes from the fact that the side wall secondary members can have significant unsupported lengths. Providing appropriate intermediate restraint helps the secondary framing system behave properly. The sag rod therefore becomes part of the overall secondary framing arrangement. However, one important engineering point should always be remembered. The exact function, size, spacing, and connection of a sag rod must be taken from the project design and applicable detailing information. We should not determine these values simply by looking at a 3D model. The 3D model is excellent for understanding geometry and location. The engineering drawing and design information are required for the actual member specification and connection detailing. This distinction is very important for professional detailing work. Now, if you are working as a PEB detailer, Here is a useful workflow. First, identify the side wall framing in the GA or framing drawing. Second, identify the columns and the secondary horizontal members. Third, locate the sag rod indications in the drawing. Fourth, check the corresponding location in the 3D model. And finally, verify the connection and member arrangement against the applicable detail. This workflow helps prevent one of the common problems in steel detailing, assuming the position of a small member without checking the actual project information. The real 3D model shown here is therefore much more than just a visual representation. It is a practical way to understand how the information shown in the engineering drawings becomes an actual steel structure. The side wall that looks like a simple elevation in a 2D drawing becomes a complete three-dimensional framing system when we see it in the model. And within that system, even a small sag rod has a specific location and purpose. So, let's summarize what we learned from this slide. First, we are now looking at the side wall framing of the real PEB model. Second, the vertical members form the main steel column system. Third, the horizontal members form the secondary side wall framing. Fourth, the sag rod is a secondary member associated with this framing system. Fifth, the X-shaped diagonal members should be distinguished from the sag rod because they represent the rod bracing arrangement. And finally, the most important point, never identify a PEB member only by its appearance. Identify it by its location, its connection, its relationship with surrounding members, and the information provided in the project drawings. Once you develop this habit, reading a complicated PEB 3D model becomes much easier. You can start with the main columns and primary framing. Then identify the secondary members. Then locate the bracing. And finally, identify the smaller members such as sag rods and their connections. This is how a real PEB model should be studied, member by member, system by system, and always connected back to the original engineering drawing. In the next stage of this video, we will continue looking at the sag rod system in more detail and connect what we see in the 3D model with the corresponding real project framing information. That way, we are not just learning what a sag rod is. We are learning where it is used, how to recognize it, and how to understand it inside a real PEB structure. Now let us take a much closer look at the side wall sag rod in this real PEB 3D model. In the previous slides, we identified the location of sag rods from the framing drawings. Here, instead of looking at the complete building or the complete side wall elevation, we are zooming into the actual 3D structural members so that the arrangement can be understood clearly. In this close view, the yellow horizontal members are the side wall framing members, while the green vertical members running between them represent the sag rods shown in this model. The close-up view is important because, in a complete PEB model, these smaller secondary members can be difficult to identify. When the entire building is visible, the main columns, rafters, purlins, girts, bracing, and other framing members can visually dominate the model. But when we zoom in, we can clearly understand how the sag rod is positioned in relation to the surrounding framing. Look carefully at the upper portion of the model. A horizontal side wall member runs across the frame, and the sag rod connects between the adjacent horizontal members. The same arrangement continues down the wall at the locations provided in the actual model. This is one of the main advantages of studying a real 3D PEB model. A 2D drawing tells us where the member is located, but the 3D model helps us understand how that member physically fits into the structure. Now look at the green vertical sag rod. It is relatively small compared with the main framing members, but its position is intentional. It is not simply placed randomly inside the wall frame. Its location is coordinated with the side wall framing system. You can also notice the small connection or fixing components around the sag rod at the horizontal members. These details become much easier to understand when the model is viewed at a closer scale. For a PEB detailer or structural draftsman, this type of close-up inspection is very useful. When preparing fabrication drawings, erection drawings, or connection details, we need to understand not only the member name but also its exact location, orientation, and relationship with the surrounding members. That is why a 3D model can be extremely helpful during detailing. Now, let us compare what we are seeing here with the concept of a sag rod. A sag rod is a secondary member used in conjunction with the framing system to provide support and stability to the associated secondary framing members. In this side wall arrangement, the sag rods are positioned between the horizontal wall members, creating an interconnected framing arrangement. The important point to remember is that the sag rod should always be studded together with the framing members to which it is connected. If we look at the sag rod alone, it may appear to be just a thin rod. But when we look at the complete framing system, we can understand why its location and connection are important. This is also why simply recognizing a sag rod from a 2D drawing is not enough for practical detailing. A detailer should be able to move from the 2D framing drawing to the 3D model, identify the same member, and then understand its physical position within the structure. In this model, the close-up view makes that transition much easier. Notice how the sag rod continues between the horizontal framing levels. The same type of arrangement can be repeated at other locations depending on the structural framing requirements shown in the project drawings. So, when you are working on a real PEB project, do not look only at the main columns and rafters. Always pay attention to the smaller secondary members as well. Members such as Girts, Purlins, sag rods, rod bracing, and other secondary framing components can play an important role in completing the structural framing system. Another important point is that the exact configuration of sag rods can vary from project to project. Therefore, we should not assume that every PEB will have exactly the same sag rod arrangement. The correct location, spacing, connection arrangement, and quantity should always be taken from the project-specific structural drawings and detailing requirements. In this particular model, we are using the actual project arrangement to understand the concept. Now focus again on the close-up. The horizontal yellow members provide the visible framing lines of the side wall, while the green sag rods are much thinner and therefore can easily be missed when viewing the complete structure. This is exactly why a close 3D view is useful for learning PEB detailing. It allows us to isolate one particular structural component and understand its position without the visual distraction of the complete building. For someone learning PEB modeling, this is a very useful workflow. First, identify the member in the 2D framing drawing. Second, locate the same member in the 3D model. Third, zoom into the member and study its orientation and connection. And finally, understand how that member fits into the overall framing system. Following this workflow can make PEB drawings much easier to understand. So, from this close 3D view, the main takeaway is simple. The side wall sag rod is a secondary framing component positioned between the side wall framing members, and its exact arrangement must be understood from the actual project drawings and 3D model. What looks like a very small rod in the complete building can become much more important when we study the framing at a detailed level. And this is the reason we are looking at the sag rod separately instead of showing only the complete PEB model. In the next part of this video, we can continue from this close-up and study the actual connection and detailing of the side wall sag rod, so that we can understand not only where the sag rod is located, but also how it is connected to the surrounding framing members. Now let us move to the end wall framing and identify the sag rod location in this real PEB project. Until now, we have looked at sag rods from different views, including the end wall framing, side wall framing, roof framing plan, and the real 3D model. In this slide, our focus is specifically on the end wall framing. The purpose of this view is to understand where the sag rod is positioned in relation to the end wall framing members, and how it appears when we look at the complete end wall elevation. First, let us understand what we are looking at. This is the end wall framing elevation of the PEB structure. We can see the overall width of the building, the roof profile at the top, the vertical framing members, and multiple horizontal framing members running across the end wall. The horizontal members divide the wall into several framing levels. These members are important because they support the wall system and help transfer loads through the framing arrangement. Starting from the sides, we can see the main vertical columns. Between these vertical members, several horizontal members are arranged at different levels. These horizontal members form the end wall framing system. The roof structure is visible at the top, with the roof slope rising toward the center. So, before identifying the sag rod, it is important to understand that the sag rod is not the same member as the main column or the horizontal wall girt. It is a comparatively slender secondary member that works together with the primary and secondary framing system. Now let us focus on the sag rod location. In this end wall framing view, the sag rod is represented as a slender vertical member running between the horizontal framing members. Because the sag rod is much thinner than the main framing members, it can be easy to miss when looking at the complete elevation. This is one reason why understanding the framing arrangement from the drawing is important. If we only look at the heavy structural members, the smaller secondary members can easily be overlooked. Notice the difference between the main horizontal framing members and the slender sag rod. The horizontal members are visually prominent because they have a much larger structural profile. The sag rod, on the other hand, is a relatively small diameter member. Therefore, when the entire building elevation is displayed on one screen, the sag rod may appear only as a thin line. For a person who is learning PEB drawings, this is an important observation. Not every line in a PEB framing drawing represents a major structural member. Some lines represent secondary framing, bracing, rods, connections, or other supporting components. Now look carefully at how the slender member is positioned relative to the horizontal framing. The rod is arranged through the framing levels. Its location should always be understood from the actual framing drawing rather than assuming that every project will have exactly the same arrangement. The number, spacing, and exact connection arrangement of sag rods can vary depending on the project design. So, when reading a real PEB drawing, we should always follow the actual project detail. This view also connects directly with what we studied in the previous slides. Earlier, we saw the sag rod location in the end wall framing drawing. Then we moved to the side wall framing and identified the sag rod arrangement there. We also examined the roof framing plan, where the rod arrangement can be understood from the plan view. And after that, we looked at the real 3D model. Now, this end wall elevation gives us another important perspective. It helps us understand how a relatively small member appears when the entire wall framing system is viewed from the front. Here is an important tip for anyone learning PEB detailing. When you open a framing drawing, do not immediately start looking only for the largest members. First, understand the overall framing system. Identify the columns. Then identify the horizontal framing members. Then look for bracing. After that, carefully inspect the smaller members such as sag rods. This method makes it much easier to understand a complicated PEB drawing. Instead of trying to understand every line at the same time, break the drawing into primary framing and secondary framing. This is particularly useful when you are working on a real PEB project. A real project drawing may contain columns, rafters, girts, purlins, bracing, sag rods, sheeting, openings, canopies, and several connection details. If you try to understand all of these components simultaneously, the drawing can look complicated. But when you isolate one component, such as the sag rod, the arrangement becomes much easier to understand. That is exactly what we are doing in this video series. Another important point is that the sag rod should not be confused with X-bracing. In our previous videos, we studied X-bracing in the roof and side wall. X-bracing creates a diagonal arrangement. The sag rod shown in this type of framing arrangement is a different secondary member. Its position, orientation, and function must be understood from the specific framing detail. So, always check the member name and its location in the drawing instead of identifying a member only by its appearance. This end wall elevation is especially useful for detailers and draftsmen. When preparing fabrication drawings or 3D models, we need to know not only that a sag rod exists, but also where it is positioned within the framing system. The elevation helps us understand its location vertically. The plan helps us understand its location horizontally. And the 3D model helps us understand how the member physically fits into the complete structure. When these three views are studied together, the actual arrangement becomes much clearer. So, in this slide, we identified the sag rod location in the end wall framing of a real PEB project. We saw the main end wall columns, the horizontal framing members, the roof profile, and the slender sag rod arrangement within the framing. The main lesson is simple. Do not ignore the small members in a PEB drawing. Even though a sag rod is much smaller than a column or girt, its location must be correctly understood when reading and detailing the structure. In the next step, we will continue from this framing arrangement and connect what we see in the drawing with the actual 3D PEB model, so that the relationship between the drawing and the real structural model becomes even easier to understand. Now, in this slide, we are looking at the complete PEB structure in 3D. This is one of the most important views for understanding how all the individual members that we have been studying come together to form one complete structural system. Instead of looking at only one drawing, one elevation, or one connection detail, this 3D view allows us to see the building as a complete steel frame. So, let us use this view to connect everything we have learned so far. First, look at the overall shape of the building. We can clearly see a long rectangular PEB structure with multiple structural bays. The building has a pitched roof arrangement, with the roof members extending across the length of the building. Because we are looking at the structure in an isometric 3D view, we can simultaneously understand the length, width, height, roof arrangement, side walls, end walls, and internal framing. This is the major advantage of a 3D model. Now let us start from the bottom. At the base of the structure, we can see the vertical steel columns. These columns are distributed along the building length and form the main vertical support system. Each column transfers the structural forces down toward its base connection and ultimately to the foundation. When we look at the complete model, we can see that the columns are not isolated members. They are connected with rafters, girts, bracing, and other secondary members to create one integrated structural frame. Moving upward from the columns, we can see the main roof framing. The roof follows the building's pitched configuration. The primary roof framing members extend from the side walls toward the ridge. Across these primary roof members, numerous secondary roof members are arranged. These members create the dense grid that we can see across the roof. Now look carefully at the roof. The repeated parallel members are the roof framing components, including the roof purlin arrangement. Because there are many repeated purlins, the roof appears almost like a grid in the 3D model. This is exactly why a 3D model is useful for a detailer. In a 2D drawing, you may see these members in a plan or elevation. But in 3D, you can immediately understand where those members physically sit in relation to the rafters and the roof slope. Now let us move toward the side wall. Along the side wall, we can see multiple horizontal members arranged between the vertical columns. These are the wall framing members, including the girt arrangement. The girts form an important part of the secondary framing system and provide support for the wall cladding. When viewed from this angle, The repeated horizontal arrangement becomes very clear. Now pay attention to the diagonal members. These are the bracing components. In the side wall, the diagonal members form braced bays. This is something we studied in detail throughout our previous videos. We looked at side wall X-bracing, roof X-bracing, bracing connections, and the connection of bracing members to structural members. Here, instead of looking at only one bracing bay, we can see how the bracing is incorporated into the complete building. Now look toward the roof again. The roof also contains its own bracing arrangement. The roof bracing connects different roof framing locations and works as part of the overall structural stability system. So, when we look at the complete PEB model, we should not think of roof bracing and wall bracing as completely separate subjects. They are different parts of the overall structural system. Now let us connect this model with what we learned about sag rods. In the previous slides, we studied sag rods in the end wall framing, side wall framing, roof framing plan, and closed 3D views. In this complete model, the smaller rod members become part of the overall framing network. Because they are relatively slender compared with columns, rafters, girts, and purlins, they may not be easy to identify from this distance. This is an important practical lesson. A complete 3D model gives us the overall picture, but close-up views are still required to understand smaller members and their connections accurately. Now look at the building from the side. You can see that the structure is divided into multiple bays. Each bay is created by the spacing between the main vertical framing locations. Within these bays, different secondary members and bracing members are arranged according to the project framing system. This repeated bay arrangement is one of the fundamental characteristics of a PEB structure. Another important point is coordination. When a PEB structure is modeled in 3D, every member has to be positioned correctly in 3 dimensions. A column cannot simply be correct in elevation. Its position must also be correct in plan and in relation to the roof framing. Similarly, a girt must be at the correct level and connected to the appropriate column locations. A purlin must follow the correct roof slope and connect properly to the rafter system. Bracing must connect between the intended structural locations. This is why 3D modeling is not simply about making a building look realistic. It is about coordinating the actual structural members. Now think about the relationship between the drawings and this model. The plan tells us where the members are located horizontally. The elevation tells us how the members are arranged vertically. The connection details tell us how individual members are connected. And the 3D model brings all of these pieces together into one spatial representation. This is why learning to read both drawings and 3D models is extremely valuable for a PEB detailer or structural draftsman. Now look at the front and rear portions of the building. The end walls close the building at both ends. Their framing arrangement is different from the long side walls because the end wall framing has its own columns, horizontal members, openings, and supporting arrangement. When we rotate or inspect the 3D model from different directions, we can understand these relationships much more easily. Another useful observation is the difference between primary framing and secondary framing. The main columns and rafters form the primary structural framework. The purlins, girts, sag rods, and other smaller members form part of the secondary framing system. Bracing members contribute to the stability system. All of these components have different roles, but they must work together as one coordinated structure. This is also where a real project becomes much more useful than studying isolated theoretical diagrams. In a simple diagram, we may see one column, one girt, or one purlin. But in a real PEB model, dozens or even hundreds of members interact with each other. You have to understand which member is primary, which is secondary, where it connects, what level it belongs to, and how it relates to the surrounding members. That practical understanding is what we are trying to develop through this Real Project series. Now look at the roof and side wall together. The roof purlins, wall girts, columns, rafters, bracing, and other members are not independent systems. They are physically connected. A change in one location can affect the coordination of surrounding members. That is why accurate modeling and accurate detailing are so important. From a drafting and detailing point of view, this 3D view can also be used as a coordination check. For example, we can inspect whether a bracing member is reaching the intended connection location. We can check whether secondary members are positioned at the correct levels. We can inspect whether the roof framing follows the intended slope. We can identify whether any members appear to interfere with other members. And we can use different views of the model to better understand complicated connections. However, one important rule should always be remembered. A 3D model should not replace the approved engineering drawings. The drawings and project details remain the basis for the actual member sizes, dimensions, connection requirements, and design information. The 3D model is extremely useful for visualization, coordination, detailing, and understanding the spatial arrangement. But the actual project information must always be checked against the approved drawings and specifications. Now, if you have followed the previous slides, you can start seeing the bigger picture. We started by asking what a sag rod is. Then we located sag rods in the end wall framing. We looked at their arrangement in the side wall. We identified their location in the roof framing plan. Then we moved into the real 3D model and looked at close views of the roof and side wall sag rods. Now this complete 3D view brings those individual observations together. So, instead of seeing a sag rod as just a small line in a drawing, we can now understand that it is one component within a much larger framing system. The same approach can be applied to purlins, girts, bracing, columns, rafters, eave members, and connection components. First, identify the member in the drawing. Then understand its location. Then understand its connection. And finally, see how it fits into the complete 3D structure. Take a moment and look at the complete structure one more time. From this single 3D view, we can see the main steel columns, roof framing, roof purlins, side wall girts, end wall framing, bracing arrangements, and the overall multi-bay configuration. This is the complete structural skeleton of the PEB before considering the final architectural appearance such as full wall cladding and roof sheeting. And this is one of the biggest advantages of learning PEB modeling through real projects. You are not only learning the name of a member, you are learning where it is located, why it is there, what it connects to, and how it becomes part of the complete building. That is the practical understanding required for structural drafting, detailing, fabrication coordination, and eventually 3D modeling. Finally, remember this simple workflow: drawing, member identification, location connection, 3D coordination. If you follow this sequence carefully, even a complicated PEB structure becomes much easier to understand. The goal is not simply to recognize a steel member. The goal is to understand the complete structural system. So, this slide gives us the overall 3D understanding of the real PEB structure and connects the individual sag rod lessons with the complete building framework. From the next stage, we can continue examining individual members and their practical locations in the real project model. Keep learning from the drawings, keep checking the 3D model, and always connect the two together. Learn the member, understand the connection, coordinate the complete structure. This is the practical approach to learning PEB detailing. Now we are moving one step further from the 2D framing drawings into the real 3D PEB model. In the previous slides, we identified the sag rod locations from the end wall framing, side wall framing, and roof framing plan. We also looked at close 3D views where the sag rod could be seen more clearly. In this slide, our objective is different. Here, we are going to understand how we can trace the sag rod arrangement through the complete 3D model. This is an important skill for anyone learning PEB modeling and structural detailing because, in a real project, a small member that looks simple in a 2D drawing can become much more difficult to follow when the entire structure is visible in 3D. First, do not immediately try to find the sag rod. Start by looking at the complete structure. This model contains the main steel framing along with the roof and wall secondary framing. We can see the repeated structural bays running along the length of the building. We can also see the roof framing, side wall framing, end wall framing, and diagonal bracing arrangements. At this stage, our purpose is not to identify every single member. We are only trying to understand the overall orientation of the building. Before tracing any small member in a 3D model, it is very important to understand the building direction. We have the longitudinal direction along the length of the building. We also have the transverse direction across the building width. And vertically, we have the height of the structure. Once we understand these three directions, it becomes much easier to understand where a particular member is located. This is especially important for sag rods because their position can be difficult to understand when we look at an isometric view. Now move your attention toward the roof. The roof contains a repeated arrangement of primary and secondary framing members. We can see the main roof framing members and the numerous purlins arranged across the roof. This creates the dense grid that is clearly visible in this model. The purlins follow the roof geometry and are repeated from one framing bay to another. This repeated arrangement provides the background against which the sag rod arrangement needs to be understood. Now remember what we saw in the roof framing plan. The drawing showed the locations of the sag rods in relation to the roof purlins. When we move from that 2D plan into this 3D model, we are essentially transferring the same information into three-dimensional space. The important point is that we should not randomly search for a thin rod in the model. Instead, we should start from the known location shown in the framing drawing and then follow that location into the 3D model. This gives us a very useful practical method. First, identify the sag rod location in the 2D drawing. Second, identify the corresponding purlin or framing members. Third, locate the same framing bay in the 3D model. And finally, trace the slender rod member through that framing arrangement. This method is much more reliable than simply trying to recognize the member by appearance. Why is this tracing process important? Because a complete PEB model contains a very large number of structural members. The main columns and rafters are easy to recognize because of their size. The purlins and girts are also relatively easy to identify because of their repeated arrangement. But a sag rod is much smaller. When hundreds of structural lines are visible simultaneously, the sag rod can easily disappear visually among the surrounding framing members. That is why we need a systematic tracing method. Now focus on one particular framing zone. Instead of looking at the entire building, mentally divide the structure into individual bays. Each bay contains its own arrangement of primary and secondary members. Once you identify the correct bay from the drawing, follow the framing members in that bay. This significantly reduces the amount of information that you need to process at one time. This is one of the most useful techniques when working with large PEB models. Now think about the relationship between our previous roof framing plan and this 3D model. In the roof plan, we saw the sag rod locations represented on a flat drawing. The plan tells us where the member is located horizontally. The 3D model then helps us understand where that member physically sits within the roof framing. This is the transition from drawing interpretation to spatial understanding. Another important point is member identification. When you look at this model, there are many slender-looking members. Some belong to the Purlin system. Some are bracing members. Some are wall framing components. And some may represent rod-type secondary members. Therefore, we should never identify a member only because it looks thin. The correct identification must come from the project drawing and the corresponding member arrangement. This is a very important habit for professional detailing. You can also see diagonal members in the roof framing. These are visually much more obvious because they form diagonal patterns across the roof bays. That is different from the sag rod arrangement we have been studying. The roof X-bracing creates a clearly visible diagonal pattern. The sag rod arrangement is comparatively subtle. So, when looking at a complete 3D model, it is very easy to notice the X-bracing first and completely overlook the smaller rod members. This is exactly why close inspection is necessary. Once you have identified the first relevant location, you can follow the same framing logic toward the adjacent bays. The repeated structural arrangement makes this process easier. However, we should still verify each location against the actual project drawing. We should never assume that every bay contains exactly the same member arrangement simply because the building looks repetitive. Openings, bracing bays, canopies, special framing conditions, and other project requirements can change the arrangement. Now focus again on the roof purlins. The purlins form the repeated secondary roof framing system. The sag rod arrangement is understood in relation to these members. This relationship is important because the sag rod is not an isolated component. Its location is determined as part of the overall roof framing arrangement. So, when tracing a sag rod in 3D, do not look for the rod alone. Look for the relationship between the rod and the surrounding purlin framing. This is where the 3D model becomes extremely useful. In a 2D drawing, several members may overlap visually. A line may represent a member that is above, below, or behind another member. In 3D, we can rotate the model and inspect the actual spatial relationship. We can look from above. We can look from the side. We can look from the end. And we can zoom into a particular framing bay. This makes complicated member relationships much easier to understand. When tracing a small member, one 3D view is not always enough. If the member is difficult to see from the current angle, rotate the model. If it is hidden behind another member, change the viewing direction. If it is too small, zoom in. And if necessary, isolate or hide unrelated members during the checking process. The objective is to make the member relationship clear without changing the actual project geometry. For a practical PEB detailing workflow, we can think of the process like this. First, read the framing plan. Second, identify the member name and location. Third, locate the corresponding framing bay. Fourth, find the supporting members. Fifth, trace the member in the 3D model. Sixth, inspect the connection or support condition. And finally, compare the 3D arrangement back against the drawing. This creates a continuous connection between drawing, model, and detailing. For a structural draftsman or PEB detailer, this skill is extremely valuable. You may receive a project containing hundreds of framing members. The challenge is not simply drawing lines. The real challenge is understanding what every important line represents and where it belongs. If a small member is missed during modeling or detailing, it can create problems later during fabrication or erection coordination. Therefore, systematic member tracing is an important part of quality control. Now step back and look at the entire building again. We can see how the roof framing repeats from one bay to another. We can see the side wall framing along the building length. We can see the end wall framing at the building ends. We can see the diagonal bracing. And within this much larger structural network, the smaller sag rod members are positioned according to the project framing arrangement. This is the main lesson of this slide. A small component must always be understood as part of the larger structural system. This also completes an important sequence in our sag rod study. We first introduced the concept of a sag rod. Then we identified the sag rod in the end wall framing. After that, we studied its location in the side wall framing. Then we located the sag rods in the roof framing plan. Next, we looked at the roof sag rods in the real 3D model. We then moved to a close 3D view of the roof sag rod. After that, we studied the side wall sag rods and their close 3D view. And now we are taking one more step backward and understanding how these members can be traced within the complete 3D structure. So, if you are learning PEB modeling, remember this. Do not try to memorize the appearance of every member. Instead, understand the logic of the framing. Know the grid. Know the bay spacing. Know the primary framing. Know the secondary framing. Know the bracing locations. Then use the drawings to locate the smaller members. Once you understand this workflow, tracing a member inside a complicated 3D model becomes much easier. Looking at this model, you may notice that the structure appears complicated because of the large number of members. But if we break it down systematically, the complexity becomes manageable. First, we understand the building, then the main frames, then the purlins and girts, then the bracing, then the smaller members, and finally, we inspect individual connections. This is how a large PEB project can be studied without becoming overwhelmed by the amount of information. So, in this slide, we learned how to trace the sag rod arrangement through a real PEB 3D model. The most important technique is not simply finding a thin line. The correct approach is to start from the approved framing drawing, identify the correct location, find the corresponding framing bay, understand the surrounding purlins or framing members, and then trace the member through the 3D model. This method helps us connect the 2D drawing with the actual 3D structural arrangement. And that connection between drawing and model is one of the most important skills in practical PEB detailing. As we continue with this real project, we will keep following the same approach. First, understand the drawing, then identify the member, and finally understand how that member fits into the complete 3D structure. Read the drawing, trace the member, understand the model. That is the practical approach to PEB detailing. Now, in this view, we are looking at the same PEB structure from another 3D angle. This view is especially useful because it allows us to understand how the sag rods are arranged within the overall structural framing, rather than looking at only one isolated location. If we look carefully at the model, we can see the complete PEB framing system, including the main structural frames, roof purlins, side wall members, end wall framing, and the secondary structural members. Among these members, the sag rods are relatively small compared with the main steel members. Because of their smaller size, they can easily become difficult to identify when we look at the complete building from a distance. That is why a 3D model is very useful for understanding their actual location. Here, the sag rods are positioned between the corresponding secondary framing members. They connect the members across the framing arrangement and maintain the intended alignment of the system. When we compare this 3D view with the earlier framing plans, we can understand an important point. The location shown in a 2D drawing is not simply a line on paper. That location represents an actual physical member that has to be installed at a specific position inside the PEB structure. In the 3D model, We can follow the member from one connection point toward the other and understand how it fits into the surrounding framing. This is particularly helpful for someone who is learning PEB detailing or PEB modeling. A plan drawing gives us the horizontal arrangement. An elevation gives us the vertical arrangement. But the 3D model allows us to understand how these two views come together in the actual structure. Now, look at the roof framing in this model. The roof is formed by a large number of parallel purlins running along the building length. The sag rod arrangement works together with these purlins and helps maintain their required relationship within the framing system. The important thing here is not to confuse a sag rod with a roof purlin. The purlin is a primary-secondary framing member that supports the roof sheeting. The sag rod is a much smaller supporting or stabilizing member associated with the purlin arrangement. Therefore, when we are reading a PEB drawing, we should always identify the member based on its position, function, and connection arrangement rather than simply looking at its size. Now let's look at the overall structure once again. From this angle, we can see that the building contains repeated framing bays. The same type of framing arrangement is repeated from one bay to another. This repetition is one of the important characteristics of a PEB system. Once we understand the arrangement in one typical bay, we can follow the same logic through the remaining bays while still checking the actual drawings for locations where the arrangement changes. This is where proper drawing interpretation becomes very important. A modeler should not simply copy a member throughout the building without checking the source drawing. The actual drawing must always be reviewed to confirm where the sag rods are required, where they terminate, and how they interact with other members. In this project, we have already seen the sag rod locations in the framing drawings. We have also looked at close 3D views. Now this wider 3D view gives us another perspective of the same arrangement. And this is important because different viewing angles reveal different aspects of the structure. A close-up view is useful for understanding a connection. A framing elevation is useful for understanding the vertical position. A framing plan is useful for understanding the horizontal location. And a complete 3D view is useful for understanding how everything fits together. For a PEB detailer or 3D modeler, all of these views should be considered together. Now, imagine that we are standing inside the actual building. Looking upward toward the roof, we would see the purlins arranged repeatedly across the building. The sag rods would appear as smaller members connecting the purlin arrangement. From the ground, these members may look very small compared with the main rafters and columns. But in the detailed structural model, their position becomes much easier to understand. This is one of the major advantages of 3D modeling. It converts the information from the drawings into a spatial representation of the actual structure. And that makes it easier to check whether a member is located where it is supposed to be. For detailing work, this type of visual checking can be extremely useful. We can rotate the model. We can zoom into a particular bay. We can inspect the relationship between the sag rod and the purlin. And we can compare the modeled arrangement with the original engineering drawings. This process helps us understand not only where the sag rod is located, but also how it belongs to the overall structural system. Another important point is that the sag rod arrangement should not be viewed independently from the rest of the roof framing. The roof purlins, rafters, bracing members, sag rods, and roof sheeting all form part of the overall roof system. Each member has its own role. When we understand how these members are arranged together, reading a PEB drawing becomes much easier. Now, look at the side wall portion of the structure in this view. The side wall framing also contains multiple secondary members arranged between the main columns. This gives us a good opportunity to compare the roof sag rod arrangement with the side wall arrangement that we studied in the previous slides. The principle of tracing the member through the structure remains the same. First, identify the member in the drawing. Then locate its position in the framing. Then locate the same member in the 3D model. And finally, inspect the connection and surrounding members. This four-step approach is very useful for anyone learning PEB modeling. It also helps prevent one of the most common mistakes in structural modeling. That mistake is understanding a member correctly in 2D, but placing it incorrectly in 3D. A member can look correct in a plan view but still be located at the wrong elevation or connected to the wrong structural member. That is why the 3D verification step is so important. In this view, we can clearly appreciate the relationship between the different levels of framing. The main frames provide the overall building geometry. The purlins create the repeated roof framing. The wall members create the side and end wall framing. And the smaller members, including sag rods, support and stabilize the secondary framing arrangement according to the project design. So, when you look at this model, don't focus only on the largest members. Try to understand the complete structural system. The small members are also part of the engineering design, and their correct location is important for accurate detailing and fabrication. This is also why a detailed PEB model can contain a very large number of individual members even when the building itself looks relatively simple from outside. A warehouse may appear to be a simple rectangular building, but inside that simple geometry, there are columns, rafters, purlins, girts, bracing, sag rods, connection plates, bolts, cleats, and many other components. Every component has to be positioned correctly, and the purpose of this series is to gradually understand those components one by one. In the previous slides, we focused specifically on the sag rod. We started by identifying what a sag rod is. Then we located it in the framing drawings. After that, we moved from the 2D drawings into the real 3D project model. We examined the roof arrangement. We looked at a close 3D view. We also examined the side wall arrangement and its close-up view. And now, in this slide, we are stepping back again and looking at the larger structural system. This gives us the complete picture. The goal is not simply to memorize the term sag rod. The goal is to understand how a sag rod appears in engineering drawings, where it is located, how it is represented in a 3D model, and how it relates to the surrounding PEB members. Once you start looking at PEB structures in this way, even small structural members become much easier to identify. So, whenever you receive a PEB project for modeling or detailing, don't immediately start modeling every member. First, Study the drawings. Understand the grids. Identify the main frames. Identify the secondary framing. Locate the bracing. Locate the sag rods. And then use the 3D model or your developing model to continuously verify the arrangement. This approach gives you much better control over the final detailing. And more importantly, it helps you understand the actual engineering logic behind the model instead of simply drawing lines and members. So, this 3D view completes another important step in our understanding of sag rods. We have now seen the same structural component from drawings, from close-up views, and from the complete PEB model. In the next part of the project, we can continue using the same approach to study other important PEB components and understand how they are represented from 2D engineering drawings to the real 3D structure. Keep watching, because the more we connect the drawing information with the actual 3D model, the easier PEB detailing and modeling becomes. Now, let's compare two similar-looking members that are used in different parts of a PEB structure, the roof sag rod and the side wall sag rod. At first glance, both members may look very similar because both are relatively small secondary members. But their location, supporting members, and application are different. So, let's understand this comparison using the real PEB 3D model. First, look at the roof portion of the building. The roof contains a series of roof purlins arranged along the length of the building. The roof sag rod works in combination with these purlins. Its arrangement is associated with the roof framing system and is provided to help maintain the required alignment of the purlins and prevent excessive sagging under load. Now, move your attention to the side wall. Here, instead of roof purlins, we have wall girts arranged horizontally between the main columns. The side wall sag rod works in combination with these girts. So, the basic comparison becomes very simple. Roof sag rod works with roof purlins. Side wall sag rod works with side wall girts. This is one of the easiest ways to remember the difference. If the member is associated with the roof purlin system, we identify it as a roof sag rod arrangement. If the member is associated with the side wall girt system, we identify it as a side wall sag rod arrangement. Now let's look at the 3D model more carefully. The roof sag rod is located within the roof framing zone. Because the roof contains many repeated purlins, the sag rod arrangement can extend through the framing bays according to the project design. In the same way, the side wall sag rod is located within the side wall framing system and works with the horizontal girts. This means that when reading a PEB drawing, we should not identify a sag rod only by its appearance. We should identify it by where it is located and which secondary member it is associated with. This is a very important point for PEB detailers and modelers. A common mistake while learning structural detailing is to see a small rod member and simply call it a sag rod without checking its actual location. But the drawing must always be studied first. We need to ask, is this member in the roof framing? Or is this member in the side wall framing? Then we need to identify the corresponding secondary member. For the roof, that member is the purlin. For the side wall, that member is the girt. So the identification process becomes roof Purlin roof sag rod and side wall Girt side wall sag rod. Now look at the complete 3D building. The roof purlins are repeated across the building and form the secondary roof framing system. The wall girts are repeated along the side walls and form the secondary wall framing system. The sag rod arrangement works within these respective systems. This is why the same term, sag rod, can appear in different locations of a PEB project. The function and arrangement should always be understood in relation to the surrounding framing. Now let's compare them point by point. First, location. The roof sag rod is located in the roof framing system. The side wall sag rod is located in the side wall framing system. Second, associated member. The roof sag rod works with roof purlins. The side wall sag rod works with wall girts. Third, purpose within the framing system. The roof sag rod helps maintain the alignment of the roof purlin arrangement and helps prevent sagging under load. The side wall sag rod helps maintain the alignment of the wall girt arrangement and helps prevent deformation. Fourth, drawing identification. The roof sag rod should be identified from the roof framing drawings. The side wall sag rod should be identified from the relevant wall framing drawings. And finally, the 3D model provides the spatial confirmation. This last point is extremely important. A 2D drawing tells us where the member is represented, but the 3D model helps us understand where that member physically sits within the building. For example, when we look at the roof framing in 3D, we can see the relationship between the purlins, rafters, and roof sag rods. When we look at the side wall framing, we can see the relationship between the columns, girts, and side wall sag rods. Therefore, the 3D model acts as a bridge between the engineering drawing and the actual structural arrangement. Now, let's make this comparison even easier to remember. Think about the word roof. Roof contains purlins. Therefore, roof plus purlin equals roof sag rod. Now think about the side wall. Side wall contains GIRTS. Therefore, side wall plus girt equals side wall sag rod. This simple relationship can help you quickly understand the member arrangement when you are reviewing a PEB drawing. But remember, the exact location, spacing, size, and connection arrangement must always be taken from the project drawings and design requirements. We should never assume that every PEB project will have exactly the same sag rod arrangement. Different projects can have different framing layouts, base spacing, member sizes, connection details, and bracing requirements. So, the correct approach is always read the drawing first, identify the secondary member, locate the sag rod arrangement, then verify it in the 3D model. Now, looking at this complete building, we can see how many different structural members work together. The main columns and rafters create the primary structural frame. The roof purlins support the roof system. The wall girts support the side wall system. Bracing members provide additional stability according to the structural arrangement. And the sag rods work with the respective secondary members. So even though a sag rod is a comparatively small member, it is still an important part of the overall framing arrangement. This is also why a detailed 3D model is so useful for learning PEB structures. When you look at only the complete building from a distance, the small sag rods may be difficult to identify. But when you understand their relationship with purlins and girts, you can trace them much more easily. You can zoom into the roof and identify the roof sag rod. Then move toward the side wall and identify the side wall sag rod. You can rotate the model and observe how these members are positioned relative to the primary and secondary framing. This method is much more effective than trying to memorize individual member names. Instead of memoizing, understand the structural relationship. Roof purlin, roof sag rod. Side wall girt, side wall sag rod. Once this relationship becomes clear, reading the corresponding drawings becomes much easier. And this is exactly the type of practical understanding that is useful when working on real PEB projects. So, let's summarize this slide one more time. A roof sag rod is used within the roof framing system in combination with the roof purlins to help maintain their alignment and prevent sagging under load. A side wall sag rod is used within the side wall framing system in combination with the wall girts to help maintain their alignment and prevent deformation. Both are secondary members, but they belong to different framing systems. The roof sag rod belongs to the roof purlin system. The side wall sag rod belongs to the wall girt system. And when you are reading a real PEB project, always confirm the actual location, spacing, size, and connection arrangement from the project drawings rather than assuming a standard arrangement. By connecting the 2D drawing information with the real 3D model, we can understand not only what the member is called, but also where it is located, what it is connected to, and how it fits into the complete PEB structure. That is the key difference between simply looking at a drawing and actually understanding the structure behind the drawing. Now you know the key difference between a roof sag rod and a side wall sag rod, and how each one fits into the overall PEB framing system. But there is another important secondary member that you will see frequently in PEB structures, the eave strut. So, in our next video, we will understand what is an eave strut, where it is located, what its function is, and how it connects to the PEB framing system. If you found this practical PEB explanation useful, please like the video, share it with other civil and structural engineering professionals, and subscribe to ACP Civil Hub for more real project PEB modeling and detailing tutorials. Don't forget to press the bell icon so you don't miss the next video. Thanks for watching, and keep learning, keep detailing, and keep growing with ACP Civil Hub. See you in the next video.